This is 2.6 notes, factoring sum and difference of cubes. Your essential question is, how do you factor sum and difference of cubes? So we have two new formulas, but they're really one type of factoring. It's the sum and difference of cubes combined, because you can see these formulas look very similar, and we'll talk about how you can remember them in just a sec. But this is one more tool you're adding into your toolbox of factoring. So we have GCF, you have the difference of squares, and then trinomial factoring. Now you have added into that sum and difference of cubes. This is a two-term thing, so when it's two terms, now you can choose either difference of squares or sum and difference of cubes. So how you can remember this is understanding SOAP. SOAP, same, opposite, always, positive. That is talking about the values. So this is for, if I had a cubed plus b cubed, that was my thing, my question. It's a plus b, a squared minus a times b plus b squared. That is always the same. A squared, a times b, b squared. SOAP helps you remember the symbols here. So you have the same, S stands for same, then you have the opposite, and last one is always positive. Okay. So same means the same as our original question. So if your original question is plus, then you have plus. If your original question was minus, then you have minus. The opposite is the opposite. So plus, the opposite is minus, the opposite of minus is plus. Okay? And then the last thing you need to make sure you know are your perfect cubes. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed, this is where we're getting into numbers that a lot of people don't know, so you want to be able to recognize these, by the way. So 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1000. Okay, so the second numbers here: 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. Those are your perfect cube numbers. And you know that what number they relate to. So 8 relates to 2, 216 relates to 6, and so on. So example 1, we're looking at perfect cubes here. By the way, a big hint is the x cubed. You always look for GCF first. There's no GCF, so this is x and 2. A equals x, b equals 2. So when I do this, it's a, b, a squared, a times b, b squared. It's always the same. A, b, a squared, a times b, b squared. Okay, and then we do the signs. So same, opposite, always positive. And there we have it. We are factored. Okay. So next one, just factoring right now. So 27 is 3, x cubed is x, and then 1 relates to 1. 1 cubed is 1. So a equals 3x, b equals 1. So we have a, b, a squared, a times b, b squared. Same, opposite, always positive. Factored. Done. Number 2. Okay, they can get complicated. X cubed relates to x. Y to the 6 is y squared. That's the cube root of it. 64 relates to 4. So a is xy squared. b is 4. So we have a, b, that's in the binomial, and then the trinomial is a squared, a times b, b squared. Same, opposite, always positive. Done. Okay, the order can be flipped, so a relates to 2, x cubed relates to x, so a is 2, b is x, a, b, that's the binomial, and then the trinomial, a squared, a times b, b squared. Make sure you keep it the same, opposite, always positive. Make sure you keep the order the same as the original problem, right? 8 comes first, so 2 comes first when you factor it out. Okay, so we get one that a lot of people mess up with because they forget, oh yeah, difference of squares or sum and difference of cubes. First, though, is GCF. So we look at our GCF. Notice these both have x, and they both have 2. So 2x, 125, x cubed, plus 64. And I took out a 2 and an x from each one. Now, I have to continue to factor. So I look, are these perfect cube numbers? Yes, 125 relates to 5, x cubed relates to x, 64 relates to 4. So 2x stays in front. Then I have my binomial, it's a, b, and then in my trinomial, a squared, a times b, b squared. Same, looking at the plus, opposite, always positive. And there it is, 2x times 5x plus 4 times 25x squared minus 20x plus 16. Last one of this type. So 343 relates to 7, x cubed relates to x, 64 relates to 4, y cubed relates to y. So 7x and 4y. A is 7x, b is 4y. That's my binomial. Then I have my trinomial, a squared, a times b, b squared. Same, opposite, always positive. And there we have it, factored. Okay, obviously that is not all we're doing, because this whole chapter is about solving stuff, either equations or inequalities, so we need to be able to solve them. So a solution of f of x equals 0, remember 0 product property, is any value that makes the equation true. For each function, write in factored form, then determine the real and imaginary solutions. We will always end up with imaginary and real solutions with this type of factoring. Okay, so first of all, remember, it must equal 0. So we take f of x, set it equal to 0. Then we need to factor. So x relates to x cubed, 2 relates to 8. So I get x, a, b, a squared, a times b, b squared. Same, opposite, always positive. That is our factored form. So the first question, so I'm going to kind of set up on the right side what your homework actually looks like. So factored is x minus 2, x squared plus 2x plus 4 equals 0. That's the first thing that it wants to do, just factor it. Then it asks for your real, and last it asks for your imaginary solutions. Okay, so we're going to do that exact same thing. So now I have it factored. Now I need to find the solutions. So we take each thing and set them equal to 0, right? The binomial equal to 0, the trinomial equal to 0. This is your 0 product property. That should be ringing a bell when I mention that now. So set each piece equal to 0, the two things that are multiplied together. This one is easy. Add 2, x equals 2. That's my first solution. The second one, if you use SOAP method, the sum or difference of squares, this is never going to be factorable. If it is factorable, you actually did something wrong. So we always have to use quadratic formula. So remember, you have A, B, C. A is 1. Don't forget about that. If there's nothing there, it's a positive 1. B is positive 2. C is positive 4. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. 4 times 1 times 4 is 16 all over 2 times a. There we have it. So it's negative 2 plus or minus 4, or the square root of 12. 4 minus 16 is, oh, sorry, that's wrong. Negative 12, that's important, because that dignifies that these are going to be imaginary, over 2. So I got to factor out that 12. So 12 is 4 and 3. 4 is 2 and 2. I have a pair of 2's with a 3 left over. All right, so I get negative 2 plus or minus 2i root 3 over 2. Okay, make sure you know how to write out i's now. So when it's a negative, we don't have a negative square root anymore. We write I to signify imaginary. Okay, so negative 2 divided by 2 plus or minus 2i root 3 over 2. Remember, we can multiply and divide. It's adding and subtracting that needs like terms. So we can write these out. So we have negative 1 plus or minus I root 3. So my real solution, x equals 2. My imaginary solution, x equals negative 1 plus I root 3, and negative 1 minus I root 3. I actually had 2 imaginary, 1 real solution. I have 1 real solution, 2 imaginary solutions from that. Okay? So remember, I always like to write them out separate. If you want to write them as a plus or minus, it's fine. But you need to make sure you understand that that represents 2 solutions. If you don't understand that, write them both out so you can remember that. All right, last example. 24x plus 81x to the 4th equals 0. Okay, you can reorder these if you want, but you don't have to. First step is to factor. So these two don't seem to match anything, except, don't forget, GCF first. 3 and x goes into both. So I end up with 8 plus 27x cubed equals 0, and I take out a 3x. So a is 2, b is 3x. So I get 3x in front, 2a, b. It's my binomial. Trinomial is a squared, a times b, b squared. Same, opposite, always positive, equals 0. That is factored form. So on your homework, that's the first thing that they're asking for. Factored form. So that's 3x, 2 plus 3x, 4 minus 6x plus 9x squared equals 0. Factor. Next, remember it asks for real solutions and imaginary solutions. So we got to solve. So we take each thing, there's 3 of them now, the one in front, the binomial, and the trinomial. Each one equal to 0 to satisfy the 0 product property. The 3 things that are multiplied together, if any of them equals 0, then we're good. Okay? So the first thing, I divide by 3, and I get x equals 0. Solution number 1. Second one, I'm going to subtract 2. So I get 3x equals negative 2. Divide by 3. And I have my second solution. X equals negative 2 over 3. And the last one, remember, we're going to set up quadratic formula because I know it's not factorable. This is standard form, not factorable, so we have to use quadratic formula. So C is positive 4, B is negative 6, A is 9. Don't forget, A is in front of x squared, B is always in front of x, C is always without a variable. It doesn't matter the order, it matters which one relates with the x squared, x, and no variable. So C is positive 4, B is negative 6, A is positive 9. Because the order is messed up, but I just know the one in front of x squared is A, one in front of x is B, the one by itself is C. So I can set up x equals opposite B plus or minus the square root of b squared minus 4 times a times c. So 4 times 9 times 4. I don't actually know that one off the top of my head, so I need to multiply on a calculator and get 144. All over 2 times a, which is 9, so 18. So I get 6 plus or minus 36 minus 144. Once again, need a calculator for that one. Negative 108 over 18. Got to factor 108. That's great. So 108, 2 and 54, 2 and 27, 3 and 9, 3 and 3. Looking for pairs. So I have a pair of 2s and a pair of 3s with 1 3 left over. You'll notice a thing. You're always going to have only a 3 left over. If you have something else, you actually did it wrong. This sum of cubes will always only have a 3 left over. So a 2 and a 3 come out in front. So I end up with 6 plus or minus 2 times 3 is 6i root 3. The one left over is root 3. Don't forget the I because it's a negative for 18. And there's the negative inside the root goes away. I turn it into an I in the front. So separate 6 over 18 plus or minus 6i root 3 over 18. And I get 1 over 3 plus or minus I root 3 over 3. So my real solutions, I had x equals 0 and negative 2 over 3. 2 real solutions this time. My imaginary solutions, I have 2 of them. Don't forget, x equals 1/3 plus I root 3 over 3 and 1/3 minus I root 3 over 3. So in this one, I had 2 real and 2 imaginary solutions. And notice in our imaginary solutions, we ended up with a root 3. And that should be the case actually for every single problem. So every single problem on your homework, if you simplify that root in the quadratic formula correctly, it should end up with a root 3. Okay. So you have your 3-sentence summary. Make sure you answer your essential question, 3-sentence summary.